Hello all, welcome to the VoIP Traffic Analysis course on Pentester Academy. Now in this video, we'll try and understand user agent client registration in more detail. So here is the scenario. We have the in-between VoIP server, and then we have two clients, Bob and Alice, and the IP addresses are mentioned here, and both of them make a phone call to each other via the server. Now what we are more interested in this video is looking at the registration mechanism. So before we move forward, let's try and understand our setup a little better. So we are using the Asterisk server. Again, Asterisk is probably one of the most popular ones, but at the very same time, it has a very steep learning curve with mostly text-based configuration files, which can be quite complicated. And this is where the free PBX guys came up with a very simple, intuitive, web-based administrative interface to interact with Asterisk. And that both of them together have been packaged into an ISO called Asterisk Now. You can download and install it. As I mentioned, Nishant will show demos of how you can get started with this installation and creating your own lab environment. I'm just going to run you through what the configuration is so that we can better understand how communication is happening. So after installation, you'll get your dashboard, and what we've basically done is we've configured two extensions, 1111 and 2222 for Bob and Alice. Now, as you can imagine, in VoIP, you need a phone number, and this extension is really the phone number. For the client software, I'm actually using MicroSIP. This is a very, very simple SIP client, simple but effective, easy to configure. And basically what we've done is we have two VMs inside which we've installed these two MicroSIP clients, and they talk via the SIP server, which is Asterisk Now. And configuration wise, well, on Alice, we basically have the extension set to 2222 and all the other stuff in here. And in Bob, extension is set to 1111. Now what happens is, Bob and Alice, both of these guys end up talking to the SIP server so that they can register their phones with the registrar service. So let's actually look at this flow sequence with PCAP files. Now I'm inside the SIP RTP directory, and I'm going to once again open up normal call two parties with Wireshark. And I'm going to click on just made a setting for auto hide the dock so that we have more real estate. So we're going to click on telephony, and I'm going to click on SIP flows just like I did in the previous video. So I can see a bunch of SIP flows in here. I'm just going to copy out all of them and click on flow sequence. Now at the very top, I can actually see that one of the phones 20.132 is actually talking to the server 2130. And then you have the other phone at 20.1, right? Let's actually make this a little bit easier to follow by naming the different parties. So if we go back in here on the very first slide, 20.132 is Bob. So this is Bob. So what I'm going to do is click on this, click on edit resolved name, make sure click on name resolution preferences, and make sure you have resolved network IP addresses turned on. Then go back in here again, click on edit resolved name. And for 20.132, I'm going to say this is Bob. Click OK. And this beautifully gets labeled as Bob if you haven't done this before with Wireshark. Now 20.130 is the asterisk server. I'm going to click on that. Basically say asterisk. And then 20.2 is Alice. I'm going to say this is Alice, right? Now this makes it a lot more intelligible because, you know, we as humans think of names, not IP addresses. And that's the reason, of course, we have domain names rather than dealing with IPs. So now I can click on telephony again, click on SIP flows, select. If you notice already we have the things labeled in properly here. Click on flow sequence. And now we beautifully get Bob and Alice. Oh, it's 20.1, my bad. Just give me a second. So, fortunately, it looks like there's no easy way to remove the resolved name. So I'm just gonna say this is, actually this is Alice. 20.1 was Alice, okay. I'm just gonna say this is some other, I have no idea what this other is. And here is 20.1. I'm gonna select this, edit resolve name, Alice. Click on telephony, SIP flows, select. Okay, so here we go. So we have Bob and we have Alice. Now, the way by which we can look at all of this is, let's close this window. Let's scroll all the way up. So we see that initially there is a register message from Bob to the asterisk server to register. Click on that and it should automatically go in the packets pane and select the appropriate packet. So here it is. So we see that the register message is being sent from Bob to asterisk, and the immediate initial response from the server to Bob is 401 unauthorized. So basically the server is actually saying, hey, you know what? I mean, you haven't provided any credentials, you're unauthorized. After that, Bob once again sends a register message, this time around with some credentials in it, and we'll look at what those credentials are in just a bit. And because the server is satisfied, it goes ahead and sends back a 200 OK saying all good, your registration succeeded. So now let's understand what is actually being sent. So I'm going to click on the very first register message and go up in here, click on that. Let's look at what is in here. We see that, well, we see a register method just like in HTTP. And if you look at it, you'll actually see this looks very familiar to an HTTP header, right? So this is a SIP packet and this is a SIP register method packet. So just like in HTTP, we have get, post and all of that. In SIP, register is a method. And well, we actually see there isn't much data apart from the from field. 1111 is the extension. You know, again, this is actually pointing to the asterisk server. So let's actually look at the next packet. Oops, the next packet in the sequence, which is the server sending back an unauthorized. Okay. Now, in the packet from the server to Bob, notice that we have a header here, www authenticate. If I expand that, I actually find that it says authentication schema digest realm asterisk, and a couple of other info. Now, just like in the case of HTTP, SIP ends up using digest authentication as well. The only difference is that it actually uses an enhanced version of it following RFC 2617, where a couple of additional things actually happen to make it more secure. So we'll discuss that in just a bit. Now, once the server poses this authentication challenge, Bob's client ends up using the password and other things and responds back to this challenge. And that's where the third register message actually contains a full-blown response here. If you notice, it contains an authorization response. And all of these fields are really the response fields. Okay. Some of them have been copied as is from the request. And some of them have actually been created by the client as a response. Client here is Bob. Now, after the server is satisfied, it sends back a 200 OK confirming, right? And we can see that just a plain 200 OK message. So now the question arises, what is actually there in this entire exchange, right? The whole digest authentication exchange. So if I were to click on what the asterisk server is sending Bob, we see an authentication header in here. Let's actually go back to our slides. Okay. So what is happening is that, digest authentication, of course, is happening, and it's a pretty complicated series of steps. So what you'd find is there is actually a multi-step MD5 getting calculated. So from the client side, to create the response, it actually takes a lot of input from what the server has sent. So if you look at what the server has sent, it's actually sent the authentication schema, the realm, the nonce value, the opaque value, the algorithm MD5, and then QOP, which is auth. Now, if you go back here to the slides, we see that we can go ahead and locate the nonce, the QOP value. Now, the username is basically 1111, right? That is actually Bob's extension. Realm is going to be asterisk, and we can see that over here. Here is the realm asterisk. Password is the user's password. Method and digest URI. So if you actually look at Bob's response, you'd find that the method is register. The request URI is SIP:192.168.20.130. Now, after that, you have the nonce count. Here we see it, which is 1 in the client's response. And you have then the nonce, the cnonce, and the QOP. And again, we can see the cnonce over here. This is the nonce value. And you also have the nonce count. Already seen that. So how is this digest response being calculated? So here is what is happening. The client now takes the username, the realm, and the password, creates an MD5 hash. Then additionally, an MD5 hash is created of the method and the digest URI. And then the nonce count, the first MD5 hash, the second MD5 hash, along with the nonce, cnonce, and QOP, again go through an MD5 hashing algorithm to create the response digest value. Now, this digest value is what is actually going here from Bob to the asterisk server. You can see that this is packet number 3. And what the server does is when it can verify that this is the value it expects, then it goes ahead and sends back a 200 OK confirming all is good, right? So you can see that the whole authentication process is pretty painfully long as far as digest auth is concerned. Now at the very end of the course, I'll actually talk about how we can gather all of this information, dump it out, and even try to crack the user's password for the system, right? But for now, we'll just focus on basically the traffic analysis. So this is interesting because all of this information is available in plain text when the traffic goes, right? So an attacker would have access to this. We'll talk about at the very end, as I mentioned, how an attacker can use it. So this is an example of a successful registration of the phone with the server. Now after that, the server sends an options packet, followed by receiving a 200 OK from the client. Now many of these really are kind of like bookkeeping with what capabilities are available, etc. Not something we need to be concerned about from a security perspective immediately. Similarly, we can actually see the second phone goes ahead and let's actually scroll up. The second phone sends basically the registration packet to the server, gets back an unauthorized, then finally responds back with an authorization response. Again, it's also calculating all of these MD5 values, etc. And finally receives a 200 OK from the server once the server is satisfied. So now that we have looked at a successful registration, let's look at an unsuccessful registration attempt. So I'm going to open up registration fail.pcap. And I'm going to go to telephony, click on zip flows, select all, click on flow sequence. And here we can see that the server ends up sending the client the first registration packet. The client sends the server and the server responds back with a 401 unauthorized. Again, all of this stuff, something we looked at with the authenticate header. Now, again, the client does not seem to have anything much, or the client is actually putting in the wrong username or the wrong password, sends back the response. But what you'd notice is the server immediately sends back an unauthorized once again. So this response from the client, unfortunately, is not valid. In all probability, the password is wrong. The client is not using the right password, and hence the digest authentication response is being wrongly calculated, and the server isn't happy about it. So it sends back an unauthorized along with another authenticate header so that the client can recalculate everything. So again, the client tries to do it, doesn't work, and this just keeps going on and on, as we can see from this flow sequence diagram, right? Great. So this is how you can identify a registration success and a fail. Now, all of these different values like cnouns, opaque, etc., these actually change on a per authentication attempt basis, simply because or else this would open up to a very simply a replay attack by the attacker if he could just get one exchange. Great. I know this was a long video, but I really wanted to cover authentication in one shot. Now we'll look at cracking this much later. So you've seen this. So if you enjoyed this video, please recommend Pentester Academy. Thank you.